Page 153, the properties of air and the structure and dynamics of the Earth's atmosphere, section D. Weather describes the condition of the atmosphere at a given time and place. The features that determine the weather are summarized in the chart below. Air temperature measures the amount of thermal energy in the molecules of the gases that make up the air. It's the average kinetic energy of the air molecules. To measure air temperature, we use a thermometer in degrees Celsius. And factors that affect measuring air temperature include location on Earth, angle at which the sun's rays strike the Earth, the amount of radiation from the sun. Air or atmospheric pressure, weight of air pressing down on Earth's surface. To measure air or atmospheric pressure, we use a barometer. It is the average pressure of the atmosphere at sea level, 1 bar. Unit for reporting air pressure is a millibar. Wind is the movement of air from an area of high pressure to an area of low pressure, described by direction and speed. Global winds blow from the poles, high pressure, toward the equator, low pressure. The rotation of the Earth causes them to curve, Coriolis effect. A wind vane is a way of measuring wind. It measures wind's direction. The arrow points in the direction from which the wind blows. An anemometer measures wind speeds in kilometers or miles per hour. Some factors that affect both air or atmospheric pressure and wind are gravity pulling air toward the Earth, altitude, air pressure decreases with altitude, density of air, pressure increases with density, temperature of air, as air cools it becomes more dense and exerts more pressure, differences in received radiation from the sun resulting in convection, and the rotation of the Earth. Moisture. Water in the atmosphere. Water may be in any one of the 3 common states in Earth's normal temperature range: solid, liquid, and gas. Moisture is measured using a hygrometer. It measures both the humidity and relative humidity in percent. Humidity is the amount of water vapor in the air. Relative humidity is the amount of water vapor in a volume of air compared to the maximum amount the air can hold at a given temperature. A psychrometer measures relative humidity using 2 thermometers, one with a wet bulb and one with a dry bulb. Some factors that affect humidity, moisture, and relative humidity are air temperature, humidity, and temperature. Section E. A weather map is used to visually display observations in order to understand and predict the weather. Weather maps use symbols to indicate locations and types of weather conditions. A large volume of air that has a similar temperature, pressure, and humidity is called an air mass. Fronts are boundaries that separate warm, moist air masses from colder, drier air masses. No matter which air mass is advancing, it is always the warmer, less dense air that is forced upward, while the cooler, denser air is the wedge over which lifting takes place. A warm front is the boundary formed when warm air is replacing cold air. As warm, less dense air advances over the denser, cold air ahead of it, the air cools and the water vapor condenses into clouds. The result may be long periods of precipitation such as rain, snow, sleet, or freezing rain, as the cold air below the warm air slows the progress of the warm air front. For this symbol, it's a line with circles that are attached to it. A cold front is the boundary between air masses when cold or cooler air is replacing warm air. As the warmer air is pushed up, it cools as it rises. If the rising air is humid enough, the water vapor will condense into clouds, and there may be precipitation. Friction between the advancing cold front and the warm front leads to cold fronts being twice as steep as warm fronts. The increased speed and steepness of slope are responsible for the more violent nature of cold front weather. In the summer, a cold front can trigger thunderstorms. The amount of precipitation is much greater at a cold front than a warm front. For this symbol, it's a straight line with triangles that are attached every so often. Because cold fronts move faster than warm fronts, they can catch up and overtake their related warm front. When this happens in the later stages of a storm cycle, an occlude front is formed, and the storm begins to weaken. This symbol is a straight line with triangles and half circles alternating. As its name implies, a stationary front does not move or barely moves. It is a boundary between two different air masses, neither of which is strong enough to displace the other. These fronts often bring cloudy, wet weather that may last a week or more. Here is an example of a stationary front to the right. Centers of low pressure, labeled L on a weather map, develop along fronts. A low pressure system is an area with lower atmospheric pressure, usually formed by a mass of warm air being forced upwards by cold air. Air rises near these areas because it is less dense. It cools, its moisture content condenses into clouds, and precipitation occurs. These systems have different intensities. Some produce gentle rain, and others produce strong winds and heavy rain. Low pressure area winds circulate in a counterclockwise direction in the northern hemisphere. A high pressure system, labeled H on a weather map, usually means that there will be sunny days and calm weather, with little or no precipitation. Air tends to sink near high pressure areas, higher density, and this keeps clouds from forming and bringing precipitation. Air flows clockwise around a high pressure system in the northern hemisphere. A weather map displays curved lines, called isobars, that connect points of equal air pressure. In most cases, they are labeled with a number that represents the air pressure in millibars. The air pressure is higher near the center of the high pressure weather system, while it is lower near the center of the low pressure system. Isobars that are closely spaced mean strong winds, which usually go hand in hand with low pressure systems. Isobars that are spaced far apart generally indicate calm, high pressure systems, such as blue skies. Other curved lines which may be displayed on a weather map connect points with equal temperatures. These are called isotherms. Okay, as you can see in this picture to the upper right, if you go and you look at this circle right here, this is an isobar, whereas these straight lines, these are isotherms.